Thank you. Thank you for inviting me to give a presentation on GIS as a basis for the transformation of the transportation sector. It's like my whole life in one sentence. I've been working on standards since 1998, working with the TC204, which is now ITS standards, that stands for Intelligent Transportation Systems. And I've also been involved with the TC211 for at least as long. And over the years, I've been working in both TCs and see the need for cooperation between the two TCs to move that transportation sector on. So I have a few slides that I want to show you on each of these topics. First, just to give you a background on where we are on the mobility and at the moment and ITS, and then I will talk a little bit about where we are heading and how we need the standards to come into play. So for those of you who are familiar with the transportation sector, there will be a few slides that are familiar for you, of course, but these are the four main trends that we see in the transportation sector at the moment. If you look at the upper left side, autonomy and automatization of the transport sector is a steady kind of trend that evolves by the day. But alongside that, we have the connected car. That is the instance when the car starts talking to each other and also talking to the road, which make it possible for the cars to drive closer together and also occupy lesser part of the road, and thereby actually giving free roads to other purposes in the future. And then in the lower right corner, you have the electric vehicle or the emission-free vehicles. That also is a kind of a trend that is not going to stop in the near future, at least. That means that the vehicle that actually use the roads will be emission-free at some point in the future, and that trend is very dominant in Norway. The last one is the shared mobility, that you actually match all of the transportation resources that are available to you with your own individual travel need, and then you get a kind of a seamless transportation offer to you in the end. All of these are infant trends at the moment. They have their own trajectory, they have their own actors and players, but when these merge at some point in the future, we will have a different transportation sector. And one of the needs that we do to get there is to standardize a lot. I would focus on automatization and connectedness in this presentation. So I just leave the other trends out for a while. And what you see here is an autonomous shuttle and an autonomous broom or street cleaner, which is pretty much the standard of where we are today, is the status of where we are today. These kind of equipment and transportation means prevails. They can do a job. They can work for us, but it's like an infant. These cannot move outside a confined area where all the geometry is known to them from before. So that's like a huge kind of missing piece still, is to move freely about as an autonomous vehicle or machine. This has to do with the technology and the maturity of the technology that we are working with at the moment. So another standards from the SIA have tried to divide this into 6 levels of automatization or autonomy. And if you move from 2 to 3, you take the move from like a driver-assisted vehicle and over to the more autonomous vehicle. Today, as I said, only the shuttles and some machines are at the 4 or 5, where you can actually use the vehicle without the driver on board. And eventually you will have a 5, maybe in 20 years, where you don't need a driver at all, and the vehicle can go all over the place automatic. Today, we have the self-driving cars firmly placed on the left side of the yellow dotted line, even though there are a lot of trials and pilots that suggest that we are further. This is probably a quite true picture when it comes to the overall assessment of autonomous vehicles in the world today. This is also supported by the Gardner hype curves, where you at the left side see in 2018 level 4 is on the downslide of the peak, on its way into the valley of despair, and the level 5 is still climbing to the top on the left side. This has moved slightly when you come into 2019, but absolutely not reassuring that we will have automated driving at any time soon. If you move into 2020, you see that we are approaching the bottom of the valley of despair, and we still have like 10 years to make it an industrial part of our life. So this is like where we are and why we also have a time to do standardization properly before we reach a stage where this is really critical for the industrialization of this area, or that transformation of the transportation industry. So we still have time. So the way we do this, at least as a viewpoint of ITS Norway, where I'm working, is to look at the possible digitalization of the infrastructure and base that on maps, and do that for all modes of transport, not only land transport, but also air, sea, and rail. So in this instant, I would just remind you of this 0 to 5 levels, which I will repeat in my next slides here. So this is just to remind you of that. And then we kind of portray our way into the digitalization of the transport sector by grouping the responsible entity, the services, and the data and standard needed to make it work in these 3 columns. And at the bottom, at the very bottom, you see the physical road infrastructure as a black line, and above that you have the road and mapping authority making digital description of the physical infrastructure and turn that into a topology or a navigable network. On top of that, you can also give instructions to the maps on the traffic rules and how it's regulated. So this is the very basis for mobility and also for automated transport and also connected transport. So the next level are using these maps, using those to add value to them, using sensors, traffic lights, traffic signs, and also the dynamic traffic information that comes out of the traffic management centers. And on top of that, again, you can actually have the fleet operators and the manual car operations, and move freely about using whatever you like. This is a picture also taken from the view of TC211, where you have the road and mapping authorities in place. But in the automotive industry, they use a different kind of GIS at the moment. That is GDF, geographic data files, and they kind of use that as an entrance to make topological maps and navigable systems for both driver support and also for automated driving in the future. So this is the big difference between TC211 and TC204, is that it's slightly different view on how to portray and how to make maps in this area. So in the levels of autonomy where we are now at 0 to 1, that will kind of equal the situation where we are today, where you use these maps for navigation purposes, more or less only. But as soon as we move into 2 and 3, things start to change. And this is where we pilot a lot of things today, and also some operations are in this area in between 2 and 3. And you see also then on the left side that the data has increased since the last slide. We have used different standards. We need the dynamic information to flow from the traffic management centers and the road administration directly to the cars. using standards. At the same time, you go on using the sensors from as you used to do. So it's like just a richer picture of how you do that. Also, when it comes to the mobility part of it, you use different standards in this stage, and you can have different mobility services. So for the TC204 and the GDF, Geographic Data Files era, we have different way of looking at this. They kind of see this as a bottom-up approach, where you use a GDF map at the bottom, then you enrich it with things that change like every month or so, and then you go to the level above where you have more like queuing and work zones and things that changes over the day. And then on the last level, you have the traffic lights and kind of where you have to interact with other kind of cars and pedestrian and bikes, where you have seconds of updating of the map. So this is the challenge that is as seen from TC204, that you need a map that is really accurate and still can host a lot of dynamic information. So this stage is where we are working very hard at the moment. But in the future, we will need even more when it comes to level 4 and 5. There will be no driver in the car necessarily. So a lot of things will change going up this stack here. And you see also that we have the car makers coming into play. Fleet management is coming into play on the lower level. And also OEMs, like that's car manufacturer, and map providers like TomTom here is coming in to play on a much lower level. And we need to cooperate and make sure that we are completely in line with each other. And this is where you read, you need a map that is like accurate in centimeters, where you need to know the curb height and all the particularities about the road and the sidewalks and stuff like that. So this is the way we are going, and this is where the work comes in, where we do in TC204 and TC211 together at the moment. And just to remind you that this is only for roads, and we do the same thing for rail, sea, and air, also in different working groups at the moment. So we are kind of working in all. And the red rings here denotes harbors, terminals, and airports, stations, which also kind of consist of internal networks that also make up a complexity that needs to be addressed. So we're trying to at least address these 5 entities and work with them from time to time, but at the moment we focus on the road. So if you look at the road and road transport, we can start with this picture where we see at the lower left side, we see ISO TC204, which is Intelligent Transportation System. This is a map made from the cars driving hundreds of times. I think this is TomTom having made that map, and they make quite an accurate view of the world. So that means that the car are actually map makers as well as the other entities. As you see on the lower right place, you have an ordinary map coming out of the TC211 and also from the road administrations. If you go one up in the upper right corner, you see a kind of a point cloud. I'm not exactly how to use that terminology, but that is even more detailed maps that is made from laser, and that will kind of enrich the TC211 GIS maps for the future. And then in the end, you have on the upper left side, you have the building information model from TC259, which has also very detailed geometries on how everything was built in the first place. And together, all of these will kind of chip in and to make sure that we have a really good picture of the world as seen from the car. And the car at the moment is seeing the world through a belt. And the belt is like an electronic representation of the road where the car can move safely and also forms the boundaries of where the car cannot drive safely. So from the 4 pictures on the last slide, you have to kind of construct belts that can be enriched by all of those means from the last slide. All those four needs to kind of enrich the belt. This is in an ongoing discussion at the moment, how this will play out in the future. So this is also pictures taken from in the middle of a discussion. And this is where we are in TC204 and TC211 in the collaboration that we do between the two TCs at the moment. So the belts are like a representation of where you can drive and where it's allowed to drive, including the traffic rules and regulations. So that makes a safe environment for the car to move. So it's really important that we have this belt concept in place. Even if this technology is not going to prevail in the end, something like it will have to prevail. So that's why we are kind of working steadily to understand what the belts are and how they can drive the work further. So how do we do this? So we have chosen to work with the three different ISO TC like 59, TC211 and TC204. I don't work much with the TC59 from the building information model, but they certainly are important to understand how they will influence GIS and in the next phase also influence TC204 and ITS in the future. So I don't know, Knut, if I might call you a doctor yet, but anyway, I took the chance to steal one figure from your thesis. Actually, I stole two, so I will come to the next one. This kind of lays out the connection between the BIM, GIS, and ITS, how they fit together and how they kind of belong together. I will recommend reading Knut's thesis. I really enjoyed reading them. So it gives a lot of insights to how this fits together. Also, in table 3 in one of his articles, this figure appears, and that shows the complexity of which standards belong to in this ecosystem of standards to kind of make this work, make this belt work, for instance, and which stakeholders that need to be involved. And it's quite many that needs to be involved in this work to make it kind of a whole. So this is kind of frames in what we are doing in at the moment between TC204 and TC211. We work with the TC204 to create a new version of the GDF and use TC211 standards to kind of foster that and to actually build it. So then we need all the basic standards from TC211 to actually do that. So we are in one way helping TC204 and ITS to be more reliant on ordinary GIS models. This makes it easier to have data fly or flow between all entities in the sector. At the moment, it's not that easy to have data flying or floating between TomTom and here and the road or mapping authority due to the lack of harmonization between the standards family. So we have set up committees to make sure that we can do that. We have on the left side here, we have the building information, which is a joint working group with TC211, joint working group 14, BIM GIS, which is led from TC59, I believe, but still very important to enrich the maps of TC211. And then again, we have joint working group 11, which is between TC204, working group 3, and ISO TC211. So this is the way at least I see how we work to fix this transformation of the transportation sector from the standards point of view. And in this joint working group 11, we have had done a gap analysis, making ISO TR 19169, which is a technical report in this area. It was initiated in 2 years ago, and it has been finished for a little while. It has been a really solid cooperation between the two TCs, and also kind of a model for further work. We did that technical report in quite a short time, and it is quite successful. This TR 19169, which is actually more or less written by Knut Jetlund, is giving advice on how to develop a new version of the GDF to make it kind of harmonized with the GIS standards. So to take all the advices that came out of 19169, we have established a new preliminary work item, 5974, which is at stage 0 at the moment, where we do look into topics like the belt concept that I talked about before, linear referencing. We are looking at the time domain, also indoor navigation, which is kind of a more and more important topic to be discussed and also to be pulled into this discussion. We did all this in less than 11 meetings, so I'm quite proud of the work that we did so far. So in the end, I would just remind you that fixing land transport is only one of four domains in transport. So we need to look at the person transport using all domains. We need to look at the freight and goods transport, using all the domains of transport. And that will take a lot of work still to be harmonized. And I know that you have a maritime presentation earlier today. We are also sort of reaching out to the maritime industry and also to the entities like AHO and YALA and IMO to set up cooperation along the same line as I showed you on the previous slide. But also we have drones coming into the picture, and we also have digital infrastructures that covers hubs like stations and terminals and stuff like that. And we need to embark on gap analysis to see where we are and where we are going and what we need to do in all these domains. So I believe this wraps up my talk. Thank you for listening.
Thank you very much, Trond, for this another quite complex, let's say, presentation of quite complex and successful cooperation here. I think there are already some comments and some people already joining with the camera. Maybe they would like to have some questions. I think there is Martin Pucher. You would like to comment something? No? Okay, so they're going back to the chat box. We have Thomas with some comments. Thomas, please.
Yes, thank you very much for the great presentation. Just two comments. One is on the Open Drive standard, which is strongly evolving over the last years, and also the uptake of that standard is quite big, at least with the big German car manufacturers, but also I think others are really now using it. There is a lot of similarities in that standard compared to what you've showed also with ITS, and I think that's really also useful to see if this can be synchronized and further synchronized. At least I think we have been in touch with that consortium, and I think we were able to convince them that in the new version of Open Drive, they should probably make use of the ISO 19100 standard series. So basing it on maybe the general feature model and also about the spatial model, etc. So there is currently, this is really strongly being considered in this group. And so there could be chances on synchronizing that. And one more comment, please, from my side is CityGML, as the standard has recently got an update, and CityGML 3.0 will be released in the next really couple of days, by the OGC. And we have also included strongly extended traffic or street space modeling, you could say. And I think this could also be very beneficial because it has a different view on the cities than BIM, because BIM, you need to know all the components, etc. And CityGML is closer to GIS and its representation. So maybe if you have not found the time or yet had any possibility, I think it's at least worth giving a look.
I thank you for those comments, and I do agree. To some extent, we have been reaching out to those entities, but we still need to do that more. Mm-hmm. OGC is on board in the Joint Working Group 11 at the moment, but mm-hmm. we simply haven't had the time to address all these issues. And we know about Open Drive and also about the CityGML that this is important features. And we are also trying to reach out to the car manufacturers at the moment, because we suspect that they have a slightly different view on this. And we need to make sure that we are on the right track, also as seen from the European car manufacturers.
Of course.
You know that this belt concept probably comes out of the Japanese Toyota and Honda situation, but will that be viable for European and American cars? So we are in that phase where we actually double checking that we are on a track that is worthwhile being on.
Yeah. I personally just can tell, because we are in a couple of projects, and one big project together with Audi, where we are looking at autonomous driving and driving support systems and the kind of 3D models that are being required. And together with the city of Munich, we are building up a very detailed street space model for entire Munich, because they want to do traffic simulation down to the lane level in order to estimate emissions in the city, and also to see what effects it will have if you replace some car driving lanes by bicycle lanes, for example, and also for e-mobility, where to put charging stations, etc. So there is currently really there are a lot of things going on in this area, and also data are currently being acquired for example, for entire Munich.
I just took note of what you're saying. I think it's worthwhile to follow up on. Thank you.
Yes. Okay. Thank you.
Thank you, Thomas, for the question. Thank you, Trond, for answers. I think before we are coming back to you, Thomas, there is another question to Trond from Martin Puchar. Please, Martin, would you like to ask the question?
Well, yes, I can do it, but I'm listening this day, this really nice, interesting topics, and I'm asking. I'm not sure that if this is the right question for this presenter, Mr. Trond, but maybe also for others. What is the relations between, let's say, different initiatives that are going on, especially related, as I know, with different topics in GIS initiative on European level, where different, let's say, topics are covered as well and try to be standardized. And maybe within this, or parallel to this, also fiber initiative, which is very strong, related with smart city domain and standardization on that level. And I didn't find any good relationship between ISO standardization technical groups here and all those initiatives I'm talking about. So maybe some other colleagues know much more about this, or is this something to be connected still?
Indeed, maybe there's some of this question can be answered partially by Trond, maybe also for some key increase. So please just respond, whoever wants to respond first. Maybe Trond, you.
Yeah, I can just say that it's a good question, and we are looking into the smart city family of standards to make sure that we are at least aware of what's going on there. When it comes to GIS, I've read through what's there, and I see that it's kind of it backs up some of the things that we are doing, but I haven't been able to actually do something about it yet. But I am aware of those two, at least GIS, and I think that smart city initiatives and standards will be needed to make this ecosystem and transformation of the mobility industry a whole thing in the end. It plays into so many aspects of the daily life in the future. So I took note of what you were saying, Martin, and I will show you for follow up on that. Thank you.
Maybe I can add something on fireware, because actually we have also had a close look at fireware in our smart city projects, and it seems that fireware is reinventing the wheel of geographic representation in their standards, and without taking notice of OGC or ISO TC 211, which I think is not a good idea, because they come up with very simple data models, and then they say now people should create domain-specific data models without ever knowing that there is already huge families of data standards out there. So I think it's definitely also worthwhile maybe approaching them. But fireware is of course not GaiaX, so there are also differences in that. I hope that GaiaX is going to have more mainstream IT support than probably the rather European proprietary parts in Fireware, but that's okay. My observation.
Thank you, Thomas, for your comments. I don't know if anybody else would like to comment the question of Martin. If this is not the case, I will thank you, Trond, for presentation once again. And